13.1 cubic roots. To cube a number, you multiply it by itself 3 times. So 3 cubed is 3 times 3 times 3, which is 27. And we say that 3 cubed or 3 to the third power. Now, a cube root goes the other way. For example, 3 cubed is 27. So the cube root of 27 is backwards, which makes it 3. So the symbol for cube root looks like the square root symbol, but has a little 3 in front, keeping it different from square roots. So the same example with symbols is a cube root of 27 is equal to 3. Because what number times itself 3 times is 27, and the answer to that is 3. Here's some problems. Let's work on together. So 1 cubed, 1 times 1 times 1 is simply 1. So that makes the cube root of 1, 1, because 1 times itself 3 times is 1. Now 2 cubed, 2 times 2 times 2 is 8. So the cube root of 8 is 2, because 2 times itself 3 times makes 8. 4 cubed, 4 times 4 times 4, 64. And then the cube root of 64 is 4. X cubed is just x cubed. But if you cube root something that's cubed, the cube root and the cube will cancel out, so the cube root of x cubed is x. Now I hope you remember when you have exponents outside, you need to multiply them. So that's b to the 6th. Now when your exponent is not a 3, unlike with square roots, we would divide by 2. But in here, we're going to divide by 3, because that's the number on the outside. So instead of dividing by 2, divide the exponent by 3 for cube roots. So 6 divided by 3 gives us b squared. All right, next one. Okay, here are some examples. Let's do the first one together. 125. Is 125 a perfect cube? And the answer to that is yes. 125 is 5 times 5 times 5. So the cube root of 125 is 5. Now, the a does not have an exponent. So I can't divide it by 3, so I'm going to leave that a under the cube root symbol. Now the other exponents, 6 and 9, I'm going to divide both of them by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So I get an answer of 5b squared c cubed, cube root of the leftover a. Now for b, 8 is 2 times 2 times 2. So I'm going to write down a 2. Now for the exponents, I'm going to divide each one by 3. Now 3 goes into 16 5 times, with 1 left over. So x to the 5th with 1 left over. 11 divided by 3 is 3 with 2 left over. So y cubed with 2 left over. And z has an 8. So 8 divided by 3 goes in there twice with 2 left over. So z squared with 2 left over. So that's your answer. 2x to the 5th, y cubed, z squared, cube root, x, y squared, z squared. So before I complete the other 4, you should pause if you want to try to complete these on your own. All right, 343. Now you can always use the cube root button in your calculator to see if that's a perfect cube. And I believe it is. It should come out to be 7. And then divide by 3, divide by 3. 3 goes into 10 3 times with 1 left over. 3 goes into 5 once with 2 left over. So put 1z with 2 z's left over. So your answer is 7x cubed z cube root xz squared. Any leftovers go back underneath. Now a lot of people will do d, the top part separate from the bottom part. But remember, you can always divide first, and that might be to your benefit. Because 64 divided by 8 is 8. Subtract exponents when they're on top. 8 minus 5 is 3. 6 minus 3 is 3. The cube root of 8 is 2. The cube root of something that's cubed is that letter. So you get 2 HR. Now when you get to E, 24 is not a perfect cubed. But normally we would do 4 times 6, but that's for square roots. When it's a cube, we do 8 and 3, because 8's the perfect cube. So we cube root the 8, and we get a 2. The 3 part has to stay underneath. And then once again, divide, divide, divide by 3. 3 goes into 7 twice with 1 left over. 3 goes into 8 twice with 2 left over. And then 3 goes into 9 3 times. So that's your answer. 2k squared m squared n cubed cube root 3k m squared. And the last one here, 250 is not a perfect cube. But 125 and 2 is, because 125 is 5 times 5 times 5. So cube root the 125, that's a 5. Leave the 2 underneath the cube root symbol. You can't really divide nothing by 3, so put the b with the 2. 12 divided by 3 is 4. Negative 3 divided by 3 is negative 1. Now, if you remember from a couple units ago, you can't end with a negative exponent. And the way you make that negative exponent positive is to move it to the denominator. And that's the answer for that one. And the third and final slide has you multiplying things together and then cube rooting them. So with A, x squared and x go together and make x cubed. The cube root of x cubed is just x. So you should times the things together. Things on the outside go times together, and things underneath the radical times together. So if you'd like to multiply these and work them out, go ahead and pause now. All right, so -2, +3 make -6. 16 and 4 make 64. D to the 4th and D cubed make D to the 7th, and then there was that lone C. Now I believe 64 is a perfect cube. 4 times 4 times 4. Now when you divide the 7 by 3, it comes out twice with 1 D left over. And then the C, there's nothing to divide by 3, so the C goes back inside with the D. Now this -6 was in the front of the problem, so times it by that 4, and you'll get -24 D squared cube root CD. Now remember, when there's an exponent outside, those get times together. So 2 and 6 make 12. The cube root of something that's to the 12th power divided by 3, that's 4. And lastly, D, there's a 3 on the outside, nothing out here. So I'm just going to put a 3 in the front. Cube root 25 and 10 make 250. 7 and 3 for the exponents will make x to the 10th. Now, 250 is 125 and 2. We did that earlier. So we cube root the 125 and we get 5. The 2 part will stay under the radical. I'll take the 10, divide it by 3. 3 goes into 10 3 times, so that's x cubed, with 1 left over, so put an x next to the 2. Now there was that 3 in the beginning, so it's going to times my 5, and I'm going to result with 15x cubed, cube root 2x. And that's the answer. And that's the end of the lesson.